Hi everybody, so moving on to our next topic, we will now be talking about solving one-step equations. And for this particular video, we will be solving equations, one-step equations with one variable using only addition or subtraction. So let's begin with some key concepts first. So we are talking about addition and subtraction properties of equality. So what do those mean? Okay, so when we say addition property of equality, it simply means that if ever you have an equation, let's say A is equal to B, anything that you add with A, anything that you add with the left side of the equation needs to be added to the right side of the equation to make sure that the equality is maintained. Same thing for subtraction property of equality. So anything that you subtract on one side of the equation also needs to be subtracted to the other side so that it will still maintain the equation. If you only do it on one side of the equation, you will have an inequality already. Okay? So that's what those two properties of equality mean. Now here are some important terms that are usually mentioned or being used when we talk about solving equations. So when we say isolate, it simply means that we need to have the variable to be by itself, to be alone on one side of the equation. We don't care if it is on the left side or on the right side of the equation. What matters is the variable has a coefficient of 1 and it is by itself. Okay? And we use our inverse operations to be able to do the isolation. Why? Because your inverse operations are used to undo another operation. So for example, subtraction is the inverse operation of addition. It undoes addition. Same thing for multiplication and division. They undo each other. Okay? So as I have mentioned, when we are solving equations, it is important to isolate the variable. And for us to be able to do that, we will be using the inverse operations. So let me give you some examples. So for this particular problem, we will be using subtraction to be able to isolate our variable. So for example, we have what is the solution of x plus 13 is equal to 27. Now remember, our goal is to isolate our variable. As you can see, our variable is x, and x goes together with a plus 13. So our goal is to make sure that x is by itself. So we need to remove the plus 13. And what is the inverse operation of plus 13? To be able to get it removed, we will be using minus 13. Okay? Plus 13 and minus 13, that will become 0. Alright? Now, regarding the subtraction property of equality, whatever you subtract on the left side, you also have to subtract on the right side. That is why we also have to apply minus 13 on the right side of the equation. And so when you solve this, x now will be by itself on the left side. This is 0 now, equals 27 minus 13. That's going to be equal to 14. And so that is our solution. X is equal to 14. Let's have this next example. So we have y plus 2 is equal to negative 6. And identifying a variable, that will be y. And as you can see, y goes together with a plus 2. So we need to remove the plus 2. How do we do that? The opposite of plus 2 is going to be minus 2. And because we subtracted 2 on the left side, we also have to subtract 2 on the right side. Okay? Positive 2 and negative 2, that's going to be 0 altogether. And so on the left side, we only have y is equal to, we have negative 6 and negative 2. Together, that's going to give us negative 8. And so our value for the variable y will be equal to negative 8. Alright, let's proceed. So this time, this second set of problem is that we are going to solve an equation by the use of addition. And as you can see here, we have negative 7 is equal to b minus 3. What is our variable? It's going to be b. And we need b by itself. And as you can see, b has minus 3 together with it. And so for us to remove the minus 3, we will be using addition, opposite of subtraction. So we will be adding 3 on the right side of the equation, which means we also have to add 3 on the left side of the equation. So negative 3 and plus 3, that will be a 0. So on the right side of the equation, you only have now just b. On the other side, you have negative 7 and positive 3, which will mean we have negative 4 as the value of our b. Okay? Let's have another example. So for this given, our variable, as you can see, is m, and m goes together with a minus 8. So how can we remove the minus 8? Opposite of that will be plus 8. And again, whatever you add on the left side, you also have to add on the other side. So that will be also a plus 8 over here. This will become 0 this time. And so on the left side of the equation, we are only left with m. And on the right side, we will have negative 6. Okay? So for this next example, I would like you to try this one on your own and see if you're able to solve for the value of our variable. Go ahead. And so solving for the variable y, you can see we have to add 3 over 2 on both sides. This will get canceled out. This will become 0. And as you can see, you will end up having a 4 over 2, which is equal to y. And 4 over 2, if you simplify, is equal to positive 2. Okay, let's move on to the next example. Alright, so let's have this example problem. So we have a helicopter descending 172 meters to be 332 meters above the ground. And this diagram here illustrates that. So what is an equation? Or write an equation to describe the situation using h as the original height of the helicopter and what will be the original value of h. Okay? So if we are going to write our equation, we know that when we talk about the word descend, this is now you will be subtracting, okay? So whatever was the original height of the helicopter, it descended. So you subtract 172. And so what now is the resulting height of the helicopter? It now is 332 meters, okay? So this is the equation that we can represent this particular problem. Now, as for solving for the original value of h, as you can see, if we need to isolate h here, there's a minus 172. The opposite or the inverse operation of minus 172 is going to be plus 172. So we also add 172 on this side of the equation, which will give us this pair as a 0. And so h is now going to be 504. Okay? That is the original height of the helicopter. All right. Thank you.